Good afternoon, everyone. Myself, I'm Shireesha, working as an assistant professor in computer science and engineering, BVRIT, Narsapur. Today, I want to discuss about compiler design subject, that to bottom-up parser. Previously, we have discussed about bottom-up parser. Now, inside the bottom-up parser, we are having LR parser. Okay, in this LR parser, this L indicates left to right scanning of the given input, and where R indicates reverse of rightmost derivation. Okay, and in this one, LR parser generally will be written as LR of k, where k value will be always less than or equal to 1. And why we need to select this LR parser means it is mostly suitable for so many programming languages, and it can be used to construct all recognize all types of programming languages. And the main duty of the parser is to detect the errors, and it will be done in syntax analysis phase that can be done with the help of LR parser. And by using these LR parser, we can construct the set of LL also. And when we are going for this LR parser representation, first we need to go for LR of 0 items. By using LR of 0, nothing but for the given grammar, first we need to go for this LR parser is divided into two categories depending upon the complexity of given grammar or construction of your LR parser. That is either by considering LR of LR items. Those LR items are called as LR of 0 items and LR of 1 items. LR of 0, it is nothing but we don't consider any look ahead symbol. LR of 1 means we need to consider look ahead. LR of 0, we are having again two different kinds of parsers. Those are LR0 and SLR1. And when we are going for LR of 1, we are having two different types of parsers. One is canonical LR parser and the other one is LALR parser. First, we need to go for LR parser. In this LR, by constructing the LR of 0 items, how we are going to construct a parser? And we need to identify whether the given grammar is related to the parser or not. Can we construct the parse representation by giving the grammar or not? We have to consider. When we want to construct the items of the given grammar, first we need to keep the dot at some position at the right hand side of the given prediction. Then how we need to consider means already we have specified here. For example, if we have any prediction called as A tends to X, Y, Z, capital A tends to capital X, capital Y and capital Z. Then for that we have the following, the set of items. Those set of items are, first one is A tends to dot X, Y, Z, means at some position we need to keep the dot starting from the leftmost end. When we are keeping the dot at the leftmost end of the right hand side prediction, parser is not verified any symbols at the right hand side of the given prediction. That's why we are indicating the dot at the leftmost end. Then after taking one symbol at the right hand side, nothing but we need to move the dot by one position. One by one symbol we have to move, nothing but at a time it is going to take or it is going to read one symbol. That indicated with A tends to X dot YZ. Nothing but parser has already viewed the symbol. It is verified the symbol called as X. It has to process the next symbol remaining input, that is called as YZ. Then dot will be moved to the right hand side position. Then the next type of representation for the given prediction is A tends to XY dot Z. Nothing but parser verified one more symbol at the right hand side, that is X followed by Y. Then we are moving the dot to the right hand side. Same, XY dot Z means it is called as reduced prediction. Nothing but right hand side everything is verified by the parser. Then dot will be at the rightmost end. If it is at the leftmost end, nothing is verified by the parser. If it is at the rightmost end, everything is verified by the parser. Every time when it is verifying the given prediction, it is going to verify one by one symbol. That is indicated with the dot representation. That's why we have to take the dot at some position for the given prediction. If we are having any prediction called as A tends to XYZ, then we need to move the dot one by one position until it reaches to the end of the given right hand side production. Next, like this, we need to construct the items for each and every production where it has to start its representation at the leftmost end and it has to move at the rightmost end. Until that, we need to find out the set of productions. That is called as, first, before constructing these items, we need to go for augmented grammar. Augmented grammar is nothing but we need to add some extra production to the existing grammar. Okay, that is, for example, if you are taking any grammar which is starting with some symbol called as S, and we are having some set of productions related to the grammar, what we have to do that is we need to add a new grammar symbol to the existing grammar. Here we are starting our production representation with the starting symbol called as S, and then we are taking here the new production symbol as S dash. Then how we need to link the new production symbol to the existing grammar is just we need to take S dash tends to S. By that we can link, we will be having the continuity to connect the next grammar symbols. Then we are going to get the production as, for example, E tends to E plus T R T, T tends to T star F R F, F tends to E R I D is your given grammar. For this, if you want to find out augmented grammar, means I am writing here one new grammar symbol called as E dash that tends to the existing starting production called as E. Then a production is called as E dash tends to E will be added to the grammar. Then overall this thing is called as the augmented grammar. From the augmented grammar, we need to start the construction of collection of items. Then how we need to construct, here we are having closure items of for the given set of I. Then if we are having any production called as A tends to alpha dot B beta is in closure of I, already that particular production is there in our item construction. Then dot is followed by a non-terminal. When we observe here, dot is alpha is a terminal symbol, beta is a terminal symbol, A is non-terminal, capital B is also non-terminal. When we observe this particular production, alpha A tends to alpha dot B beta. Here dot is followed by B. Whenever we are having dot is followed by a non-terminal, what we have to do? We need to add the production. For example, for B tends to gamma is a production. B tends to gamma is a production. What we have to do? We need to add this B tends to dot gamma to the existing item. Okay. In initial item, for example, in the current item, we are having the production called as A tends to alpha dot B beta. Then here dot is followed by B. Then what we have to do? We may have some production related to the B. For example, B tends to gamma is a production. Then we need to add the dot to the right hand side of your given production. This particular production will be get added. This will be get added to this particular closure of the given item. Okay, if we are having the item called as like this, due to this we need to add this production. Then for this example, for the given set of this particular example, then first what we have to add? First we need to start from this production. E dash tends to dot E. By adding dot at the right hand side, we need to start the representation. When we observe this particular production, dot followed by E is there. Then we need to add the production related to the E. Okay, what is the production related to the E? E tends to E plus T and E tends to T. Two productions are there. According to this particular rule, if A tends to alpha dot B beta is there, here E dash tends to dot E is there. According to the above rule, what we have to do, if dot is followed by non-terminal is there and the productions related to that particular non-terminal will be added. Then we are adding E tends to E plus T and E tends to T will be get added. These two productions will be added by using the above rule. Okay, first production and second production by adding the dot at the starting position of the right hand side production. E tends to dot E plus T, E tends to dot T. When we observe these two production, E tends to dot T is there here. E tends to dot T is there. Then once again dot is followed by non-terminal, add the productions related to that particular non-terminal. Two productions are there, those two productions will be added. From the above grammar, we are having two productions, those two productions will be added. Then T tends to T star F, T tends to F will be added by adding the dot. When we observe this one, once again here dot followed by non-terminal is there, and we need to add the production related to that particular non-terminal. In the given grammar, we are having two productions, that is F tends to E or F tends to ID. By adding the dot at the right hand side leftmost position, then we are adding these two productions. When we observe this one, here dot is followed by left parenthesis. It is not a non-terminal symbol. Nothing will be added by this. Dot followed by ID is there. It is not a non-terminal symbol. Nothing will be added. By this, we need to conclude the construction of the current item. Okay, this is the construction of the item. This process we need to repeat until there will be no more new items will be constructed, and we need to find out the transition on every input symbol. Nothing but every symbol of the grammar. Dot followed by E is there, we need to move the dot over E. Dot followed by T is there, we need to move the dot over T. Like that we need to repeat the process. Okay, for that we need to construct the DFA representation. By that we will get some set of new items. Okay, whenever we reach to the point in such a manner that there will be no more new items constructed, we need to stop it by seeing that every production will be there in reduced format. Nothing but dot will be there at the rightmost position of the right hand side part. We need to verify for each and every production is in the reduced format or not. Until that, we need to repeat this particular process. And for example, for initial item, when we have taken and the items are added like this, and we need to find out the transitions for the initial item. When you are finding the transition for the initial item, first one is dot is followed by E. Then we need to find out the transition on E because dot is followed by E. When you are finding the transition on E, we need to move the dot to the right hand side position. Then you are going to get the production as E tends to E dot. And one more production is also there, that is dot followed by E. Then in that production also we need to move the dot to the right hand side. Previously dot is here, now we are moving the dot to the right hand side. When you are observing this particular production, dot is there at extreme right hand. When you are observing this production, dot followed by plus is there. Then dot followed by non-terminal, nothing is there in this one. So no more new items will be get added. Dot is followed by E, only two productions are there inside your initial item. No more new productions will be added. Consider this one as a single item. Name it as a new item called as I1. Next, like that. Next dot is followed by T is there. Means we need to move the dot over T. Then we need to write the transition as T. Then when you are writing the transition as T, just we need to move the dot over T. Then you are going to get the production as E dash tends to T dot. Then for this next production also dot followed by T is there. For this also we need to repeat the same procedure. We need to move the dot over T. Then you are going to get the production as T tends to T dot star F. And when we observe this one, dot is followed by which symbol? Here it is a star, nothing but terminal symbol. Nothing will be added to this. And we need to verify any other production where dot is followed by T. No, only two productions are there. For those two productions, we have moved the dot over T. Then we have constructed a new item. It is not the existing one. Name it as I2. Next, dot is followed by F will be there. For that also we have to write. Okay, dot is followed by left parenthesis symbol is there. For that we found the transition as dot followed by left parenthesis. Then we need to move the left parenthesis to the right hand side. Left parenthesis, dot and E we have to write. When we observe this one, dot followed by E, here it is a non-terminal symbol. Here we need to add the productions related to E. How many productions are there? Okay, 2 productions are there related to E. Then how we need to add? By adding dot at the right hand side. By adding dot at the right hand side. When we observe this one, once again dot followed by T is there, T productions will be added. Okay, dot followed by F is there, F productions will be added. Okay, we need to repeat this particular procedure because dot is followed by non-term. By that we are going to get one more item. We need to name it as a new item. Next, dot followed by F is also there. For this, what we have to do? Just we need to move the dot to the right hand side. Then you are going to get it as T tends to F dot. This is also a new item. Name it as I3. Previous one is I4. And one more thing is there, dot followed by ID is there. For this also we need to make the transition and we need to move the dot at the right hand side. Name it as I5. From the initial item where the dot is following, for all we need to find out the remaining items by moving the dot by one position. Then you are going to get the items as I1, I2, I3, I4 and I5. And we need to see once again in the initial item, we need to move the dot to the right hand side. Everything is completed. On E it is completed, on T it is completed, on F it is completed, on left parenthesis completed, on ID it is completed. And we need to repeat the same process for the constructed items by moving the dot to the right hand side until there will be no more new items are get constructed. Okay, when we are constructing this, we need to construct by using goto and closure algorithm that I'll explain with the table construction. Okay, and for this we are getting all these set of items. Okay, on T, on ID, on F. Okay, next we need to move for the initial item. Dot will be moved to the right hand side over plus. When you are moving over plus, what you are going to get? Plus dot T will you are going to get. Then we need to write the items of T, productions of T. When we are writing the productions of T, dot followed by F is there. Then F productions we need to add. Then I1 is completed. For one production it is already there in reduced format and second production we are moving on plus. And nothing is there to find out the transition on the first item called as I1. Then go for I2. For I2 also we need to repeat the same process. When you are having E tends to T dot and T tends to T dash star F. T dot there is nothing to add. When we are having T tends to T dot star F, on star we need to move the dot. That's why we have given the transition like on star. Then we are moving it on star. You are going to get some set of production. First production is T tends to T star dot F. Then F productions will be get added. Okay, 2 productions will be get added. Nothing is there on I2. Then go for I3. I3 we are having reduced production. No more transitions are possible to find on I3. Go for I5. I5 also same thing. Already it is reduced production. Dot is there at the right, extreme right end. No more new transitions will be added for this item. Then we need to construct on I4. I4 dot followed by E is there, T is there, F is there, left parents is there and ID is there. For everything we need to find out. On E, whenever we are finding on E, this is the first production we are going to get, that is F tends to left parenthesis E dot right parenthesis. We are moving the dot over E. Then next production is E tends to E dot plus T. And by seeing this particular item, is there any possibility to construct, to add any other item, any other production to this existing item? Means there is no. Because by moving E, dot is there at position followed by terminal symbol. Nothing will be added. Dot is followed by plus is there. Nothing will be added. Then dot is followed by T will be there. Dot followed by T is there. For this we are going to get the production as E tends to T dot. and one more production T tends to T dot star F. Okay, when we are observing this, E tends to T dot and T tends to T star dot F. Already it is going to the second item. So we can write this particular transition as I2. No need to construct the new one because already it is there in I2. On F also already it is there, that is I3. On F we are having I3. On left parenthesis it is self loop. Okay. On ID it is going to I5. So no need to construct the new items. If there is any possibility of constructing new, then we need to construct the new. Otherwise keep it as it is. I4 is completed. I5 already reduced. Go to I6. I6 also repeat the same process. Dot followed by T is there. Dot followed by F is there. For everything we need to find out we got these items. Okay. When we observe the productions, first production is in reduced format, second is in reduced format, third is in reduced format. Okay. And fourth T tends to T star F is also in reduced format. Okay. And T tends to F dot, it is in reduced format. F tends to E, it is also in reduced format. F tends to ID, it is also reduced format. After constructing all this, no more new items will be get constructed. Then we need to stop the constructed canonical collection of items. Then after stopping this, what we have to do, whatever the items that we have constructed, represent inside the table. Okay, and when you are representing inside the table, how we need to represent? Basic LR parsing model is we need to give the input, stack application will be there where you need to apply the LR parsing algorithm. By that we are having two different type of entries. One is called as action entries and other one is called as goto. We are going to generate the output as whether the given input is accepted by the given LR parsing algorithm or not. Okay, this one is the parsing table. First we need to construct the parsing table. From the parsing table we have to go. Then how you need to construct the parsing table? Okay, for the parsing table construction, first we need to go for collection of LR0. Okay, from this collection of LR0, we need to go for action entries and go to entries. Two different type of entries are there. Inside the go to entries, what we are doing? Okay, first if A tends to alpha dot AB is in one item, then go to of this particular item on A is equal to, for example, IJ is there. Then we need to write the action entry as shift followed by J. Whatever to which item it is going. Shift, nothing but S we have to write here. S followed by J we have to write. For example, I1 on A, it is going to some I3. Then we have to write as shift followed by this particular item number called as I3. Then how we need to write action entries? Action entries, it is nothing but we have to write for the non-terminal symbols. Okay, whatever the non-terminal is there, for the given non-terminal you need to write the action entries. If no entry is there, it doesn't means that it means that a error entry. And at last we are having S dash tends to dot S will be there, that you need to write at under I on dollar, that should be accepted. Okay, by using this we need to construct the parsing table. Here the table is constructed. Okay, initially I0 on ID, to where it is going we need to verify. I0 on ID, first we need to see inside your representation. I0 on ID, first I0 on ID, it is going to I5. That can be represented as I0 on ID, it is going to I0 on ID, it is going to I5. That can be represented as S5. I0 on left parenthesis, it is going for I4, that is S4. Shift actions can be entered. Okay, go to will be given for non-terminal symbols. I0 on E, it is going to I1, that can be represented directly. There is no shift and reduce, directly we have to write the item number. I naught on T, it is going to F. I naught on F, it is going to 3. Like that we need to enter the items. Whereas inside the action entries, either you need to enter it as shift or reduce. Reduce where we need to enter under the follow set symbols or for all the symbols. For L or 0, for all the terminal symbols of the grammar, we need to enter the reduce production. Whereas for SLR1, only one difference is there. Only the follow set of left hand side non-terminal symbol, we need to enter the reduced productions. That is the main difference. By following the difference, we need to fill the entries. Whereas 1 on dollar. Okay, 1 on dollar. What we need to write? This is the 1 on dollar. We are having the entry as inside I1, we are having the reduced production for the augmented grammar symbol. Okay, for the augmented grammar symbol, the follow set is by default it is dollar. Okay, so 1 on dollar you need to enter it as accept because augmented grammar symbol is added to accept the given grammar. For that purpose, we need to enter that particular entry as accepted. Okay. Remaining inside I2, we are having the reduced production. Okay. And what reduced production? Second production inside the grammar is reduced. Okay. What is the second production? We can see here. Here we are having inside I2, E tends to T is there. E tends to T is the production number 2. First production is E tends to E plus T. And second production is E tends to T. Okay, this is your second production that is there inside item 2 in reduced format. We need to go for the follow set of E. Under the follow set symbols of E, what we have to do? We need to enter it as R2. Follow set of E is right parenthesis dollar and plus under this we need to enter. Whereas for LR parser, for every symbol we need to enter. Whenever you are entering for every terminal symbol, we are going to get some conflict here. Whereas for SLR, you are not going to get any conflict by entering only for follow set symbol. That's why it is called as SLR1. We are considering one look ahead by constructing the follow set. Reduced productions will be entered only for follow set, whereas reduced will be entered for all terminal symbol. This is the table for SLR1. Next. Inside I3 also what we are having the reduced production. Okay, for the reduced production we need to enter reduced followed by production number. Like that we need to fill the entries depending upon the items. All the entries will be get filled inside the parsing table. After constructing the parsing table, we need to verify do we have any multiple entries for the single cell. Multiple entries for single cell. When we observe the table, we don't have multiple entries. For this table, we don't have multiple entries. Whatever the grammar is there, that we can call it as SLR1 because we don't have any multiple entries. Then we need to verify the acceptance of input by parsing the input. Just we need to parse any one input and we need to show that the given input is accepted by the given grammar with the help of the table. For this one also we are having the algorithm representation. Okay, by using the algorithm only we need to parse the given input. We need to first, by default we don't have any representation inside the stack. We need to push the initial item onto the stack. That is nothing but initial item number is I0 will be pushed onto the stack. Okay, stack representation, what symbol you are going to process, what is the input, what action we are going to perform. When we are coming for the action representation, when we are performing the action, either we need to shift the current input symbol onto the stack, or we need to reduce the top of the stack, or we need to raise the error, or we need to accept. These are the 4 different type of actions. That action will be entered inside the action column. Whatever the input that you are going to process, that will be represented inside the input column. And the symbol is nothing but which symbol you are going to shift, that we need to specify. Either we are reducing or we are shifting, that is represented inside the symbol representation. What is the current stack representation when you are performing shift or a reduce operation? Okay, that will be done by using this algorithm. When we are seeing this algorithm, action of S comma A is equal to shift T. For example, I naught on A is equal to some I4 is there. Okay, I naught on A, 0 on A. 0 on A we are going to 4. Then I4 is there. This indicates your shift by 4. Then what you have to do, whatever the current input is there, that will be shifted on to the stack, and 4 also will be shifted on to the stack. Otherwise, if I naught on A is equal to some reduce entry is there inside your table, either we may have shift entries or reduced entries or error entries or accept. These are the 4 different type of entries that we have seen inside the table construction. Okay, then we need to see the entry for the given item number followed by the input symbol. If this is the case, shift 4 is there, then what you have to do, current input symbol is shifted onto the stack followed by the item number. Otherwise, if the case is the given item, for the given input symbol, if we have the action as reduce, then what we have to do, just we need to reduce the top of the stack with the left hand side non-terminal. If reduce, how you need to reduce, A tends to B is there. Then we need to pop 2 into beta symbols from the stack. After popping 2 into beta symbols from the stack, what we have to do, whatever the top of the stack is there, on that one we need to find out for the non-terminal whatever the item number is there, that we need to push. Otherwise, if action is action of S comma A is equal to accept, then we need given input is accepted. That we will see with this particular example. Initially nothing is there, stack contains 0. Okay, 0 on ID, current stack content is 0, current input symbol is ID. We need to go for the table 0 on ID. 0 on ID, what we are having, shift followed by 5. What is the action we need to perform? Shift action. What do you mean by shift action? Current input will be shifted onto the stack followed by item number 5 will be shifted. 0 ID 5. 0 ID 5. Next one is current top of the stack is 5. Current input symbol is star. Then 5 on star. 5 on star we are having reduce followed by 6. Then 6th production we need to reduce. What is the 6th production? F tends to ID. Okay, F tends to ID, this is your beta, and beta value is 1. 2 into beta symbols will be popped off from the stack. Okay, 2 into beta nothing but 2 symbols, ID 5 will be popped off. Then what we have to do, left hand side non-terminal is F. 0 on F. 0 on F3 will be pushed. Here we are pushing 3. Next we need to verify 3 on star. The process will be get repeated until we need to reach the last operation is 1 on E. Okay, 1 on E, what we are having, 1 on dollar, not E. 1 on dollar, what we are getting, accepted. Other than this, if you are going to get any other input, any other process, means you are going to get error. Like this 1 by 1 input symbol will be get processed with the current top of the stack. Either we need to perform shift or we need to perform reduce. The same process, this process will be get repeated until the end of your input. End of input will be indicated with the dollar symbol. When we reach to the end of the input, then we need to verify what is the type of the action. If the type of the action is error accept, then the given input is accepted. If the type of the action is error, then we cannot accept it. Error message will be given to the user. This is the processing of LR0 and SLR1. Next class we will learn about CLR and LALR. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.